Hi, guys. Welcome to The Social Block, the podcast that explores the intersection between blockchain technology and society. As always, together we cover all sorts of topics like how this tech is going to change our world, our culture, us as individuals, our institutions, all of that jazz. You already know the drill. I'm really excited about today's episode. I've been wanting to do it for ages. It's about zero knowledge, and I know that it's all the rage in blockchain, but it's actually been around for a really, really long time and is also applicable outside of the blockchain space. So I finally found someone who's very, very qualified to talk about zero knowledge and teach me about it as well. You know, I'm not a tech person, so it's been really great to have someone explain it to me. We covered quite a diverse range of topics, including technical ones. So if you want to learn a little bit about the techie tech bit about ZK, stick around. It's right at the start of the episode. Our guest today is Pavel Sinelnikov. He's a DevRel lead at zkM.io. Hi, Pavel. How are you doing today?
I'm doing great. How about yourself?
Yeah, pretty good. To start us off, can you tell us a little bit about yourself and what you do?
Absolutely. I am the head of DevRel for ZKM. We're building a ZK VM based on the MIPS instruction set. So I can go a little bit more into detail on what that means, but I could just leave it at high level, and then we can go exploring.
We can explore that a little later if you want.
Awesome.
Okay, well, we can go ahead and start if you want. So let's start with the basics. In layman's terms, what are zero-knowledge proofs and how can they benefit us?
Absolutely. Zero-knowledge proofs are essentially a way that I can do typically two things. One is I can make things private. So in the zero knowledge aspect of zero knowledge is that I can essentially do some computation with some private input data and essentially have an operation that results in whatever that results of those private inputs are. So those could be like private transactions. Those can be identity as well. So you can put in like your personal information, but then out comes a result like is this person over 21? So zero knowledge for privacy or zero knowledge proofs for privacy is one important aspect. But there's also zero knowledge proofs for verifiable computation, and that's more of I don't really care about the data that I put in. You know, it could be public, but essentially it's data that I'm putting in, and I guarantee that the execution of that data was correct, and the results of that operation I can use in many different ways. Typically, right now, like the more common use cases are associated with blockchain because it really adds like a good match, like in terms of just the verifiable execution, and then you can essentially use this verifiable execution to then do things like scaling solutions like layer 2s and also bridging, which is also an important use case that we're working on as well.
So hang on, I'm just gonna backtrack to the second example. Where is the zero knowledge element there? So you have, your what was it? Verifiable computation was that the phrase? Like you have some kind of like process going on, and you can verify that it's true. Is it the process that's the zero knowledge bit, the bit that remains private and hidden?
Think of it like this: there's a black box, right?
Okay.
You can put in private inputs into the black box, and that's the zero knowledge for privacy. But you can also put public inputs into this black box.
Okay.
What the black box doesn't really matter. I mean, I guess it does in the, if you're putting data and some execution. But what matters is that the data that you put into the box and the data that you get out of the box is verifiable. And so the zero knowledge component means that this whole entire process is succinct. So that means that I can verify the whole entire process from start to finish and can guarantee that the execution happened in this way. And then I guess it's more useful when you have the code open. So I guess I would say that that aspect of zero knowledge isn't necessarily like you don't include all information of the execution. So that's where that zero knowledge component still applies. So you don't need to execute the entire program from start to finish. You can essentially do this operation outside or off chain and then bring the results on chain. So that's where the zero knowledge.
Yeah, so that's where the gap is.
Yeah, exactly.
Okay, thanks for clarifying that. So, I mean, I don't know how much of the podcast you've seen. I'm not a technical person. I'm very much in the comms field of blockchain, and I know zero knowledge is huge, but I really just know kind of like the basics of it. So I know that there's different types as well. Like, can you lead our listeners through like a couple of the basic types or like categories of ZK?
Yeah. So there's ZK for privacy. So that's one of the big use cases. I think WorldCoin is utilizing that ZK for identity specifically. So they're essentially taking they have like the orb, and then you can take a ZK proof of your retina, and then that basically generates a verifiable identity to you as an individual. So essentially, you're able to use ZK proofs to attest that you are a person in a verifiable manner. So that's one use case for the privacy / verification of data. The other examples, the succinctness, is solutions like zkSync, where I'm a layer 2 and I take individual transactions that occur on my layer 2, and I can essentially prove that I executed these transactions, and then here's the resulting output of those transactions. And so that allows me to take a lot of individual transactions, bundle them, compress them together.
Is that the batching?
And then essentially...
Is that what they mean when they say like the batching transactions application for ZK?
Yes, exactly,
Okay.
exactly. So you're taking individual transactions, combining them all together, and then just sending that individual state of the results of the execution. So if I had like 20 transactions and they're all like 1 + 1 + 1 + 1, I can just send that resulting state, or the state diff, which is basically like, after I apply these transactions, here's the difference from when the before and after component. So that's how ZK proofs are used for that in terms of the execution.
So in my head, I'm having a bit of a like taxonomy issue, because when I was trying to read up on the basics of ZK, like something that kept coming up was interactive versus non-interactive, and like zkSNARKs, zkSTARKs. I don't know what those are. And I think the last one I read about was bulletproofs. Is there some kind of like, do they fall under the ZK for privacy and the succinctness ones that you just mentioned in some way?
Yeah. So typically when we talk about ZK proofs in the blockchain context, we deal with non-interactive proofs. And the difference between non-interactive and interactive is that with interactive proofs, essentially I can come, it's like a communication between the prover and the verifier. So I come to you and I basically say, as the prover and verifier. Let's see, who starts where? So the prover proves the execution. The verifier makes sure that the execution was correct. The verifier doesn't know what data is put in. They essentially take the information that the prover provides and then is able to verify that the prover executed, or the prover knows that information. So
Like,
in an interactive proof,
it's a yes or no type. This is here or it is not here. The verifier verifies. So the prover gives it information and the verifier is like, okay, so yes, you do have a green scarf in there, but it doesn't really process anything else that's in there. It's just like, yes, no.
exactly. And so with that interactive proof, it essentially it plays a game essentially. Like imagine if I have like two balls in my hand, and one ball is a green ball and the other is like a red ball. And then I essentially I can essentially show the balls to you, and then you can attest that if the balls were swapped or not.
Okay.
Oh no, sorry. You show that to me. Sorry, you show that to me, and then like you're trying to prove if I know which ball is green and which ball is red. And then what you do is you then put it behind your back and then you show it again. You could have swapped it, you could have not. Either way, I have to answer, were the balls swapped?
Is it the same? Yeah. Okay.
And then the chances the first time is 50%, right? Like I could make a lucky guess. But then the more you do it, the more you show the person, the more you reveal it then it essentially decreases by half.
Yeah,
then you have like a
you get to that moment of like certainty.
Yeah, exactly. You have a small percentage that the person is cheating, or like the person is essentially.
Does that happen? Like,
such a small amount
at the end? Is there a percentage left? Because I'm assuming like you keep going into infinity like that, right?
There will always be, so it'll never go to like 100% certainty. So that's the part where it's
that's
like
the ZK catch.
Mathematically, yeah. Like I mean, I guess it could be like mathematically secure in this way, where there's just so many zeros where you basically without that reasonable doubt, you can guarantee that person knows that information.
Yeah, there's like after a certain moment, you don't really need any more proof. You're like, okay, I believe you.
Exactly. I got it. You don't need to show me any more of these like color balls. Yeah.
Stop.
So that's active. Active proofs are like you essentially you generate a single proof, and typically these are SNARKs or STARKs. So these are the two main types of non-interactive proofs. SNARKs are essentially they're created. They have a few different qualities associated with them. The differences lie in, for example, quantum resistance. So STARKs are quantum secure. So essentially, you can use them, and assuming that quantum computers come into existence, and then you're able to basically make a what's it called? You're able to make computation that can beat most of these let's say signing algorithms. STARKs will remain secure, but they do come with, let's say, downsides. So one is like the proof size. So STARKs have like a larger proof size, which means that it costs more to post STARKs than it is for SNARKs. SNARKs as well have a trusted setup. So essentially, I have to do a ceremony with various different types of people, and essentially people that come into this ceremony need to contribute. Typically, they contribute like their own like public key, and then as long as one person burns their private key, then the randomness that you put into this is guaranteed. So as long as, and that's the assumption with SNARKs, is that you do have a trusted setup in those cases. So like there's different types of downsides to using either method, and there's also upsides, right? sometimes you can even combine Starks and Snarks together. And so that's actually what we're doing. We generate a Stark and then recursively prove that Stark within a Snark. So it's like a recursive Snark.
So you can actually use ZKs within ZKs to combine the power, and basically you get the best of both worlds. You're using the strengths of one and then like using that to cover the weaknesses of the other. That's really cool.
Exactly. And then with this, you're able to get something that's well, secure as well as succinct and smaller in size and
more efficient.
Of course. Exactly. There's limitations to different models, and like a lot of ZK projects are looking at, what trade-offs do I want to have in these different types of mechanics? Like, do I want to prioritize speed over size of proof? Do I want to prioritize maybe I want a very small proof, but it might take 5 hours in order for it to generate. So, and then like, in our case, we're doing general purpose zkVM. And so that basically means that we have, typically you need to create a specific circuit of information. Like, is this condition true, assuming that the execution is correct? And typically you can make very efficient circuits. And then there's like languages for this circuit development, like Cairo, for Starkware. But in this case, since we're making a general purpose, there's a bit more of a, let's say, design consideration for having it be efficient. So ours right now is I would say less efficient than the ones that you can just manually develop with these language specific circuit creation languations. And
okay.
So there's different trade-offs. That's like the sum of everything. It's like different strategies for computing different things, which every ZK project has their own like flavor on like what the best way to do it.
Yeah. What I guess it matters in what you're trying to achieve in terms of what you'd prioritize, and then where your strengths and weaknesses would be. So I do get it, but before I really want to ask about use cases, and obviously that's probably going to be the part people are most interested in, like what do we use this for? But before I do that, I want to kind of pick at that what is, like how do we understand zero knowledge proofs, maybe by going a little bit backwards into it. What are some misconceptions that you find people often have about zero knowledge proofs? And from there also like the other limitations or, you got what I mean.
Yeah. So like one of the big probably misconceptions is that ZK is just for privacy. Like or like ZK is essentially related to that you're essentially hiding information for, I guess, privacy specific purposes. Like it is possible to actually include both the privacy component and the verifiable computation. And that's something also that we're in the future potentially working on with within our own, let's say, entangled rollup design. But I'll get into that a little bit. But it's essentially that ZK can be used for many different applications, not just for hiding information. Like the verifiable computation probably is the more prevalent version of ZK in the ZK tech. So I would say like that would be the biggest misconception that it's present is that there can be other use cases that use the same process as ZK proofs, but for a different purpose. Because very maneuverable, we're seeing like applications from like zkML, and we're
that's
seeing
machine learning, right?
With
the ML.
Yeah, exactly. And then there's definitely like a whole branch of innovation that's coming from just like it's kind of the technology. There's barriers to the tech, the hardware limitations, let's say, and the proof generation times and all of that. But definitely we're seeing like a lot more of these like use cases being built on top of each other that sort of harmoniously integrate. And yeah, definitely want to see like both those verifiable computation use cases and both the privacy use cases. And yeah, like in terms of the let's say limitations of the proofs, like the biggest, I would say, limitation is it's a very small community. I mean, there's still like a lot of talk, and it's like research focused. But I think that one of the big limitations is that it's a bit more difficult to start within the entire ZK space. It's like in order to start, you're sort of like directed towards, oh, read this 250-page book called Moon. And it's like to understand, you know, how do I even get started within this system? And then in our case, we've just launched our testnet.
Congratulations!
And essentially, it's a thing that you can run on your local computer. If your local computer was like a NASA computer.
Oh,
okay. Sorry.
Oh well.
It's like the minimum requirements for it is like 64 gigabytes of RAM with like a 16-core CPU, which isn't that bad, but that rules out basically all laptops. That rules out like any let's say non-modern computers, and you're going to wait a long time for generating the proof. So the recommended, I would say, like RAM and CPU is like in the 128 gig, 256 gig. It's like you have to have high amounts of computing hardware in order to even run proofs. Or, and what we're working right now is creating like a prover network where you can essentially take computation and you give the inputs to us, you give the program code to us, we can run it within this environment, and then we generate that ZK proof and then just send it to you. So that's how.
How is that like? How does that hold up in terms of like trust? Like, is it trust in you guys as an institution to run that for you, and then to give the result and make sure that it's accurate, or is it like there's some kind of publicly verifiable way to see how you're running it on, you know, your machines and everything?
Yeah, because like the beauty of the ZK proofs is that it doesn't really matter which machine it runs on, because the proof essentially proves that you ran the computation.
Oh, okay.
So it can be run on any type of untrusted. With you know, if someone has bad intentions and wants to, you know, maybe like mix program inputs or maybe like falsify the output, the proof will be invalidated at that point. Like,
okay, yeah,
that black box just wouldn't produce that proof if a person tried to maliciously alter it from their machine. So that's what it like the
which is why it would make business sense to have one institution or like that has the machine, the computational power necessary to run the ZK proof, right? And then spit out the result. Because it's still safe and verifiable.
Exactly. And also if we go down, like if whatever let's say, you know, companies go bankrupt or whatever, the code is open source. The ability to prove any code, although you do need a bigger machine in order to generate that proof, you can still do that on your own. You don't have to rely on a third party in order to provide this service. So that's where like the power comes to the end user, and then you're able to basically make like trustless, even though like in these computing environments, you're essentially dedicating it to some other trusted device. you can do so trustlessly as well. And you have that option in both cases. Actually, when you're doing that privacy use case, Alio, for example, you have to run it on your local machine. So they do have like also like high requirements, but in this case, if you want things to be truly private with the transactions that you're making, then you have to run it on your local machine. Because if you give public input, what we call it a prover network, then everyone will basically know what data that you're putting in as inputs versus just the data that you're locally having on your machine as inputs.
I forced myself when I was like thinking of this question. I was like, okay, I need to think of like one of the misconceptions I definitely had before, like doing a little bit of research and like listening to you now, was like that I really would think of ZK just as like a privacy thing, which evidently it is not. But I tried to think of like, okay, what other misconceptions could there be out there? And the first one I kind of thought about was that I feel like a lot of people who don't understand zero knowledge and blockchain for that matter, like I think they get grouped into one here, is that there's this thought that like this anonymity that it can provide on the privacy side can equal no accountability. But I don't necessarily think that's true. And I wanted to ask how you think it would be possible to retain accountability. Say now you're using like digital identity, for example, but just because we don't know who you are doesn't mean that like we don't know certain details enough to know and to keep each other accountable. How could it do that?
So, have you heard of Tornado Cash?
Yes, I have actually. It's the one where like a lot of people, if you want to like just not link, like create an obvious trail of like one of your wallets to the other, like you put it in Tornado Cash, it bunches a bunch of like transactions like that, and then it just like executes them, I guess, together, and then it like distributes, right? So you don't know
exactly
what, like they all go into one place, spin, and then they come out, right?
Exactly. It's like it's a mixture, and essentially it's been, let's say, the target of a lot of, let's say, hackers, and like North Korea has been
also a lot of criticism, like regulatorily, it's been a lot of criticism in its direction.
Exactly. Like I think there was like a sanction against it as well. So by the U.S. government, and so the reason why is because
money laundering, right?
Exactly. Like you cannot right now. You can't dissociate yourself. Like let's say you want to inherit that privacy, you can't dissociate yourself from a person that, let's say from North Korea that comes in and essentially puts in X amount of money, and then now you have essentially stolen funds inside of your wallet because you wanted that privacy. There's no way to differentiate between the person that's putting funds in illegally and then the person that puts funds in legitimately.
Yeah, who just wants to keep their wallet anonymous.
Exactly. So there have been other solutions out there, and like Zcash, as well as Railgun. They have the ability to essentially you can input I forgot what they call it, but you can input it to showcase to, let's say, an auditor that my transactions haven't been intermingled with people that are, let's say, that have those like the hackers, the people
blacklisted wallets and stuff like that.
Exactly. So you can you can verify that these transactions haven't mixed funds with those like entities, and so as a result, you're able to maintain privacy externally. But if you're getting audited and they want to see like which transactions were you involved in, you could still provide that information to those people with that like reveal key essentially. So in this way, you can still maintain privacy but in this way, like regulatorily compliant privacy. And if that answers the question about accountability with
It
the
does,
actions
yeah.
that you're doing, that's essentially where like projects are adding like these additional features, because I believe in privacy, but at the same time it's very difficult to differentiate if everything's like intermingled and like shady business is happening,
Yeah.
especially you're
I think it's very important, to keep the world actually functioning, non-criminally pervasive place rather than, just create chaos. I think we're definitely past that part where we're trying to disrupt and like be really on the edge of things. I think we're at that part, and this technology's development where we're trying to actually make it functional and secure. Another misconception I was thinking of, and it comes back to what I said earlier about, how we're looking for like a yes/no answer to like, does this person know the difference? Like if we swap the two little balls, right? The green and the little red ball in our hands. But is it a misconception about zero knowledge proofs to say that they can prove anything? In that, like, does it have to be like a binary yes or no, or like a mathematical like value or whatever? Or can it be something more subtle or more, I don't want to say complex, but like what if the criteria are, to give a really crazy example, more artistic? Like what if it's just kind of like, does this painting have something that resembles a face on it? Or like this painting of NFT, whatever, something digital, which is kind of like a subjective-ish concept. It's not that precise. So can we prove it or verify stuff like that with ZK, or can we not, is my question. So can it prove anything?
Yeah, that's a very good question. I actually did a brief presentation about that topic at ETH Denver.
Just now?
Although like not with the context of, sorry?
Was that just now?
Yeah. It ended, I think, like a week ago or a little bit. Yeah, like a week ago. So it's still fresh in my mind. Although I didn't go into mostly the use cases that I think of mostly that would apply with ZK is those binary yes or no. It's like, is person over 21? Is this transaction batch valid? I guess those are more of like the simpler use cases for this type of model. But I guess within I'm not familiar, let's say, entirely if it's being used for like those more artistic scenarios. Like I haven't really been exploring, like, for example, zkML, which it's more of you still have the verifiability of, is this the inputs that are going into this machine learning model, is that transparent, is that correct? Do we know like what's going in there? And as a result, we're able to rely on the information provided by the AI chatbot without it having tremendous biases, for
hallucinations.
Example. So I know that. That there's definitely like everyone's competing.
Did you hear the news? Which was it, Gemini, that had like overcorrected and was actually like biasing again against like it like white people? This is very recent news, but I don't remember what its bias, like where it had overcorrected was.
Yeah, like I guess right now, like the arms race between the different types of AI and machine learning companies, like Google, and you have like OpenAI, and then now you have like X, Elon Musk coming in.
God. Here we go.
Everyone has their own versions of what inputs can go into here, and then like the outputs. We only see the outputs. We don't really see the inputs. We don't see.
We don't know what it learned. But where it trained itself.
And so because we're not able to see that, it's very difficult for us to like we can only see the end results, and that can lead to a distorted worldview. especially when a lot of people use that as their main motive, like, hey, ChatGPT, what should I do today? But so like in those cases, I do believe that there might be cases where ZK can be used for more like that the artistic, not artistic, but like in the sense that
Subjective.
it can be rather than like a binary. Like I do think that, but I do have to look into that for to be 100% certain. I absolutely know it can be used for binary. I'm like
Yeah. I mean, I'm
certainly certain.
pretty certain of that myself. I was just wondering because this is one of the things that I was like, what could misconceptions be? And that was the first thing that popped into my mind, that it can prove everything. Because like, can everything prove anything? There must be some things that you can't necessarily mathematically verify, or maybe you can. So I was just like wondering, but it's a good conversation. It's a good mind picker, I guess. But the thing I really think with ZK is, and it's something that picks my brain like very philosophically, is that I think it's revolutionizing the concept of trust. It's because a lot of people think that it's not about trust and that trust is going to disappear, but I actually think we're just kind of moving what we trust. So we don't necessarily like we're trusting code, but by proxy of that, we're still trusting the people who created it. We're still trusting the developers behind these proofs. And yeah, so I think that kind of leads me into like, with all these use cases we're going to talk about, it's always, we're creating trustless systems, but we're always getting to that point where like we're ultimately trusting someone, right? The creator.
Yes. The idea is like, if you have open source code and then you release it to everyone, and then everyone has a chance to look at it, evaluate it, break it, reuse it, eventually maybe, we've seen smart contract vulnerabilities have the same thing where people audit it, but then still there's a vulnerability that causes a $500 million hack, and then like,
Yeah, I feel like I have a good example for this, which is like really stupid. But if we have like a zero knowledge proof that's just like, can you prove that this person is over 21, for example? And the proof goes and like it takes all these people's digital identities, and it's just kind of like yes, 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 yes. But like if we're talking about, say, the drinking age in Europe, which is 18. If you input 21, if the person who created the proof is just like put in 21 as like the value that we're looking for, or like is using the proof, well, I mean, it's human error and the code can't fix that. It can't know. So yeah.
Yes.
It's like how you set it up.
I guess. Yeah. That's the big that's the big question. How do you remove people from the equation of the process where machines do it best? It's like the same idea of self-driving cars, right? You essentially have a certain amount of people on the road that lead to, I don't know, like 40,000 deaths per year, and then self-driving cars
crash into an ambulance in San Francisco. Do you remember that?
I don't.
Do you miss that one? I think it was San Francisco. But yeah, so I feel like what I was going to say was, this is why I laughed when you said self-driving cars. Because yeah, technically they can probably drive way better than people and stuff. But now that we're developing them, like there must be something that we're missing if a self-driving car is crashing into an emergency vehicle. We're missing something here.
Exactly. Or even I know that Uber did the tests for essentially with it was like guided self-driving car, and then it hit a person.
Oh my God.
Like the person that was crossing.
Christ.
So like definitely in this case, like I guess there's going to be a certain point, I think like a certain threshold where it makes more sense to adopt it rather than not. Like
I think I really understand what you mean. We need to reach the level of this technology where it's able to be adopted, but is not a risk. And it's the same with blockchain as well. I mean, I think you see, Bitcoin is like so old at this point. This is not something that's brand new, but it's taken us years and years and years and developer onto developer onto developer to develop Bitcoin and its network into something that's actually, it makes more sense to use it right now rather than not to, because like I'm pretty sure that, some 7 years ago, it didn't make any sense. No one even knew about it. So I think that's what you're saying. It's all about how developed it is. It's just very new.
Exactly. And then like these ZK proofs are great, but at the same time, you have to convince the bar or whatever, the club, in order to adopt it. You need to convince the bouncer. We're all in the same boat of everyone's already comfortable with what's your ID, and then I can just take a look and within 2 seconds tell you yes or no.
Yeah. It's a conversation I have a lot with when we talk about education and, on-chain qualifications. It's all fine and dandy to issue them on-chain or have digital identities. The question is, will this be recognized, and how do we get it to be recognized in enough places where it makes sense to have it? So it's the same, I think. Yeah.
And the easiest use case right now is anything that can be integrated with blockchain. Like anything that, for example, the easiest use case is it's like crypto building for crypto. That's where we're seeing the best adoption. But then once we have a sort of ecosystem where it's easier to move money, for example, from country to country using blockchain. Now we have people that are coming on, and then you can leverage the benefits of, for example, the ZK tech, where you have like native security essentially within this ecosystem. So I don't see that bouncers are going to come in and install an app on their phone and then have it like you're gonna come to the what's it called, the club, and then you're gonna pull out like a QR code about like your proof. And no, I don't see that, I guess, happening
yet.
Very early.
But let's adopt digital identity first and then go from there.
Exactly. Like we bring people in to the blockchain ecosystem, and in that way, it's kind of like in a sense like a walled garden, kind of like the Apple ecosystem, where like it's everything works inside of this thing, and maybe it doesn't work like outside of it, but then like it just makes more sense to adopt what's inside, because it's just that much more like efficient or cost reduction, and then that's where I think we'll see like the most adoption, is that crypto not adapting to, or crypto and ZK not adapting to like the real world activities. It's more of like the real world activities taking and leveraging the tech that is provably and verifiable essentially globally, without requiring anybody to say, yep, that's correct. You don't have to trust anyone. Instead, you trust the open source code and the devs, which can make mistakes.
In a way, yeah, you are decentralizing trust a little bit, because you get to the point where like if it's open source and a lot of people are working on it and constantly changing it, there is a level of, you're not trusting one single entity again, but that's a little bit of a different story. But we kind of, I guess, already moved on to the use cases a little bit. What are the biggest killer apps? And I definitely want to talk about, layer twos, all the blockchain applications. We can start with that one if you want.
Yeah, absolutely. I think right now the current like killer apps, the ones that are being like utilized today, are layer twos. We have different like layer two scaling solutions. We have zkSync. We have Tyco. We have StarkNet. We have essentially like a huge assortment of like ZK based layer twos that are coming in, and they all have like their own flavors of how they generate proofs. So Scroll, for example, they have the ability to take individual, let's say batches of transactions, and then just have them being proved by multiple provers, and then aggregated all in one. So that assuming speeds up the time where I could post the data on chain, which basically, as soon as the data reaches on chain, that basically confirms it to anyone looking to, let's say, verify that this, let's say the action happened. So if it's posted on layer 1 Ethereum, that means that this action happened and it was proved by this system. And so like that's how we see this provable or succinctness being used and by these layer 2s.
Speeds up
right
transactions.
Now everything is like in development.
Yeah. So it's
exactly.
a scalability narrative. And do gas fees play into that? So is it like possible because you're, batching all these transactions, you're verifying them all in like a bunch and like basically popping them back into the system? How does that affect gas?
Yeah. Because you're taking a lot of transactions and then essentially combining it into one, essentially state diff. And proof as well. So you have like the output, which is the state diff, and then you have the proof that is in combination with that. And although the proof is a bit chunky, it needs to be stored. It needs to be stored on L1, and it does require like a sizable amount. But you're taking individual transactions and then essentially decreasing the size instead of posting each one of these transactions on layer 1. And essentially now you have gas prices that are for example shooting up, and now it's $50 per transaction. You're like, whoa,
oh God, yeah. I'm like, no, thank you.
Exactly. It could still retain like a low amount that is still usable for day-to-day purposes, and so that's where it's like really good to take transactions, batch them together, and then post them on L1 to have them eventually finalized. The other use case, and one that we're working on with zkM, is the ability to not only prove computation on EVM solutions, but also on non-EVM. So right now, everything is basically resolved on Ethereum. Like layer 2s in essence, like they post their transaction, the state diffs and the proof on layer 1. What we're trying to do is we want to actually take incompatible ecosystems. So, for example, even like EVM to EVM. So Avalanche, for example, is also an EVM blockchain ecosystem. But then there's also Solana. Solana is using Rust, and they have their own like Rust VM. And then you have, for example, you have Aptos, which is Move. Move is a different programming language. And so you have Aptos, and then you have Algorand, so which uses AVM, and then you have Near, which is using Near VM. So you have like all these blockchains that have VMs. And right now, like a big issue is how do I integrate these incompatible blockchain ecosystems in a way where I don't have to trust a third party. Right now, we're using bridges, right? Bridges that bridge to different solutions. But a lot of bridges work in a way where I give you $10,000 and you promise me that you'll give that $10,000 back on
another chain
or Algorand.
Yeah.
Yeah, exactly. And it's all based on promises.
On
right?
trust.
Like
on trust.
Exactly. Trusting random people from who knows where they live, who knows who they are, where for example, there's been a bridge hacks, and I think like the largest hacks that happened in this space came from bridges, because they're just basically big honeypots where if I have $600 million locked in a contract, that's a pretty big reward for me just to exploit all of these these solutions. So in these ways, in this way specifically, like how can we trustlessly migrate funds from one blockchain to another? And so we're working on a system called the entangled rollup, where you're essentially able to generate a proof that you've executed this transaction. And this is also part of the we call it the universal L2, where you can take a transaction, provably burn it. So like burn it in the sense like send it to the 0x000 address. So you remove the funds from circulation. And then you can generate a proof that you've removed those funds from circulation. And now you have a proof that essentially says that you burned 100 USDT. And you can take this proof and you can redeem it on a completely different blockchain. Like it at this point, it doesn't matter which blockchain you do it on. You essentially have a proof that I do not have this amount of funds, or like I removed this amount of funds from circulation.
So yeah, that eliminates the double spend issue if like you, but then how does that guarantee that on the other side you get the same amount? Like how does that obligate them to give you that amount?
So this is where like the module and like we call it universal L2 because essentially the layer twos would be communicating with each other. It would be it would essentially implement the same standard where if I receive a proof that this token was burned on whatever other chain, I'm able to mint a corresponding amount of asset to your wallet. And so as a result, the layer two needs to adopt this type of mint function using the proof as input. So in this way, we can essentially connect all the L1 chains using L2s as a means to, one, the scalability benefits, and the second is that interoperability, and then finally the third is that native cross-chain bridging, not relying on a trusted third party. You're essentially relying on the proofs themselves to be generated correctly. And then as a result, you can redeem X amount of tokens on a completely different chain. And in this way, again, I don't have to rely on another consensus mechanism in order to facilitate this. I don't have to wait for a finalization thing. It's all essentially generated using proofs and using native layer one security, not relying on external validators, which is essentially the trusted party, which then they can choose to not fulfill that request.
So to wrap this up for our listeners, there's like, I guess we kind of covered like three really like strong killer apps for the blockchain space. I guess the first one was the batching of transactions for blockchain's efficiency, essentially the scalability element. Then we talked about like that gas fee, so the efficiency and the financial sense. And then the last one that you just mentioned was the bridging between chains. Okay.
Yes. Yeah.
Those three guys.
All of them are like the computation. Yeah.
Yeah. Well, I feel like there's another sphere it's not so blockchain native, but it's something that's really on my mind a lot when it comes to ZK. The Internet of Things. I feel like that's a really big one. We have all these smartwatches that monitor our heart rate or whatever. We've got all of our, our phones. We've got our Google account and our Amazon account linked up there. And there's so much information with these also centralized kind of entities that we're using. So between the Internet of Things and stuff like Amazon Web Service or, Google accounts and stuff, where can ZK find application in those two spheres?
So in terms of utilizing, let's say, non-blockchain activities, so the IoT devices or just using like external servers. So one is the use case of, let's say, AWS servers within the ZK space. AWS servers still play a huge role in current blockchain systems, but ideally, everyone runs their own node, everyone has their own validator, and not relying on, let's say, a centralized party in order to validate these transactions. But as I said, when relating to verifiable computation, it doesn't matter which computer verifies that the data. right? I can essentially take that same amount of computation and I can use it on AWS. I can also take IoT devices, right? There's a lot of them, and a lot of them talk to each other, right? Communicate. And we have so many, and even though they have small amounts of like processing power, right? Very minuscule, we still have the ability to potentially use these individual IoT devices as a form of cluster computer. So if we take like millions of devices, combine them all together, we can essentially take, potentially we can take operations that might take an individual computer, like minutes to hours, and then you can reduce this to, assuming that the latency is okay, we can reduce the computation time by a significant amount using these IoT devices as well. So that's how we see that like IoT devices, AWS servers can sort of coexist within the ZK space, mainly for the proving aspect of the verifiable computation. But then we have so much computing power in relation to what exists today. Security cameras, we have like drones, we have like what's it called, like smart fridges and everything. So imagine all of these devices just at a consistent rate, just verifying proofs while they're sitting idle. And in this way, we can essentially not depend on, let's say, a single AWS server to generate the proofs, or like a single hefty server. We can essentially depend on the network of hundreds of thousands, millions of these individual IoT devices.
Like decentralized cloud computing, sort of. Is that where we're going? Or like decentralized cloud computing, is like that where we're going with this? Because I feel like the one part... The one part of what you're saying is the basically harnessing all that computational power that's just lying around. But then the other one is like we have the centralized cloud computing, all of these, servers, platforms that we're all using in our daily life, but we have an issue with the fact that, if they go down, that's an issue. But then we've got the decentralized idea that comes in, and it's possible to do that. So I feel like what you're saying also lends itself to that.
Yeah. There's other services that do provide essentially that, like, for example, like a decentralized GPU network, and then people can like come in, and I know there's an old project called Golem, for example. They also do like that decentralized cloud compute. But in essence, I would say there isn't a big need for decentralized cloud computing. I mean, outside of we recently see like the AI space, the machine learning space, we need to compute like all of this like gene folding, for example, that like we do see use cases, but I think the proofs, and when proofs become more, let's say, when we have faster proof generation times, when we have more adoption of ZK, it will become that essentially way that people would just naturally operate. I don't have to rely on a third-party service provider to do all this. I can rely on the network of all these like interconnected devices that can then generate proofs for day-to-day activities. Right now, again, we're only seeing the big use cases of it within the blockchain space, and that's kind of the limitation is you have that walled garden where it's like everything works within this garden, but as soon as you take a step out, it's like what
do I do now? Yeah.
How like verify like shipping containers using ZK, like that's kind of like the head scratcher.
But although it would be good because I mean it's possible. You just need people to recognize that, and for it to be recognized more widely to be usable, right? If you're verifying
exactly.
It is possible technologically. Anyway, you know what
like the chicken
and the egg problem, exactly. I feel like with the IoT devices, I was thinking the privacy application is particularly strong because, you want to share all of this data about your body, say with your smartwatch, but maybe you don't want it to know who you are, your nationality, all those kind of things. But that's just, my crazy thoughts. We are kind of coming up to time, so a couple last questions just for the end. I wanted to ask what unexpected societal changes or changes to our lives you think zero knowledge proof might provoke or get.
I think for me, I'm kind of like in part in the trenches within like the blockchain space. I've been in cryptos for about 7 years, so it's kind of like the only thing I think of. So I have obviously a bias within like the how it like revolutionize a lot of things. But at least within this space, I can see it having lots of impact in regards to securing billions of dollars, trillions of dollars in assets for that bridging example, for example. It in that way, I think the financial security of applications is one, like a very big priority. And then as a result, we have when things are financially secured, then we can have more, for example, privacy use cases, which I think is going to be like a really big thing for ZK proofs. Is that now I can essentially have like native private transactions on a public ledger, right? That one of the big limitations for Ethereum and most blockchains is that everything is public, everything is revealed, and then there's no way to like unreveal it. And so that's like if your identity is exposed or someone knows your wallet address, they can like
game over,
airdrop you whatever tokens that you can never remove. And I mean, for this to be adopted, for crypto to be adopted for more than just like the financial DeFi aspects, I think that having the ability to privatize transactions, privatize your wallet address, and then to be able to selectively disclose to people that in the same way where in the same way that people don't know who you're emailing, other than the people that you're emailing. So it's in this way where I think that ZK would provide that catalyst for having more of these daily life use cases where it just makes more sense to use blockchain tech than it does to use anything else that exists. And but that of course might.
Yours was so practical. Like your idea was so practical, because mine is so like wildly philosophical. I was coming from this place of like the, blockchain, one of its mantras is don't trust, verify. And I thought of that like, okay, what would that do to society if, zero knowledge is for me one of the epitomes of don't trust, verify. But it also adds like the privacy element to that. And then that becomes this whole thing of like, are we going to like, how like when a society, for example, like in really developed countries, they have like really strict laws and everything. And for example, like even if you cross the road, if you jaywalk, you can get seriously fined. And that kind of stuff just doesn't happen in places like Eastern Europe, for example. Like you're not going to get fined for jaywalking. But what I feel like that leads to is that if the rules are too strict and it's just like everybody is suffocated and being controlled by the rules to the point where they don't even have to think, common sense and problem-solving skills, for example, become less and less ubiquitous. Whereas in places that are problematic, people are quite active in their minds. So when it comes to trust, like what if the don't trust, verify situation leads to the same thing with trust? We lose our ability to differentiate, our ontological ability to say what's true, what's false, as people in our interpersonal relations. So yeah, in one way, I'm a bit worried, like unexpected societal change. Will society become too stupid? And then alternatively, will it just become too transactional? So even if it's okay that we have ZK and everything, is it just going to become so transactional? Which for me is just like a little bit not an interesting world, I feel like we need to retain that ability to make meaningful connections and trust. I feel like trust is an important concept, and it's important to completely eliminate it in processes like when we're dealing with our finances. But there's other social processes where I'm a bit worried about removing trust. I feel like it's important for our humanity. I know that's all a bit futuristic and philosophical, but yeah, mine was really totally different from yours.
No, I really like that point where you essentially say that we remove the human aspect of things. I think people will play a big role. It's that where people can go wrong is like for example, you have the voting, right? You have
Oh yeah, we didn't talk about voting. That's such a good application of ZK. Yeah. Oh well.
You essentially the idea of that trust, like I want to come to my community and I want to feel like a part of it. I want to feel like I'm a trusted representative and like that whole community feel. But at the same time, like I also want to know, what the outcome of certain things that we hold very, very dearly in society as well, like the voting systems, the transactions. I don't think that the world will, I would say, just be entirely transactional based. I think that we will have a place where communities will thrive and do like DAOs, for example, right? Vitalik, I think, recently said that DAOs cannot be like mathematically proven. So essentially, there is no mathematical formula to solve DAOs, and that's really the beauty of it. Like the idea of organization, if it can't be mathematically solved, then people need other people to coordinate to do certain actions. And I don't think that, if Vitalik can't figure it out, then I don't know who. So I think there will still be like within everything. It just we're just removing the inefficiencies of like the non
the things where it's better to not have to trust. But yeah,
exactly.
It's like we need to draw the line somewhere. We need to know which things to use trustlessness for and then which things to leave a healthy level of trust. I think I get that. I really relate to that as a sentiment. Well, I think it's time for us to wrap up. So I always ask my guests at the end if there's something they want to share, like a message or specific information with our listeners just at the end of the episode.
Yeah. I mean, in anything, if anything, we're essentially trying to get more people into this space. The amount of Solidity developers or blockchain developers just in general, I think it's been like 20,000 active developers I've seen, but it could have changed recently. But the amount of ZK developers or the amount of people that are in the ZK space are just a fraction of that number. I don't even know the exact number since it's like not even big enough to conduct a survey on, or at least the one that I've seen. So like we're trying to build up our own like education hub and a way where people can like share resources, contribute, learn from each other. So like we have a lot of resources that like I think like our website zkm.io and definitely like we're always looking for more contributors, more people that even like that don't know and want to know and don't want to read a 250-page book.
Oh,
yes.
Nobody has time anymore.
Exactly. It's like, oh man, can you just summarize it in like 2 sentences? It's like
ChatGPT.
We could probably
summarize this book. Well, that's such a great sentiment. And I'm really glad that you're into the education of it because, and even just participating in today's episode, because I feel like I don't understand zero knowledge well enough. I don't have time to read 250 pages about it. And I don't have a practical use case for that either. But yeah, so I really appreciate the contribution to education and also your time today. So guys, that's our episode for today. And we'll see you next time on the Social Block. Thanks for joining us, Pavel.